analysis. And inside the asymptotic analysis, what are the three things we need to be remember? What are the, by using this, what is the analysis is going to be done between the functions? And suppose if we are having three types of sorting algorithms, and what are the three types of sorting algorithms? We are having bubble sort, and we are having some selection sort, we are having some insertion sort. And while suppose if you are in your project, some sorting algorithm is needed, and then depending on the situation and depending on the scenario, you are going to choose one best algorithm. How you are going to choose that best algorithm here means depending on the what time and space complexities, and which algorithm is efficient, and depending on the logics we are going to be choosing, and depending on the situation we are going to choose that algorithm in our project. For choosing that means we are going to depend on what we are going to depend on what is the concept we are going to be dependent here means to choose an algorithm means we are going to be dependent on something as complexity. Nothing but what are the two types of complexities we are going to have here means time and space complexities. We are having some time two complexities we are having as well as what time and space complexities. mm, and inside the while analyzing the algorithms, we are going to consider some three cases. What is meant by the best case, and in which type of, for which type of input it is going to execute fast, for which type of input it is going to it is going to take maximum time, and for which type of input it is going to take the average time. And best case means we are going to be called it as what minimum time required for the program execution. And average case means we are going to call it as what average time required for the program execution. Average time required for the program execution, we are going to be called it as what average case. And what is meant by the worst case means we are going to call it as what maximum time required for the program execution. These are the three things we are going to be considered for what analyzing the what asymptotic notations. Analyzing the what asymptotic notation. And inside the asymptotic notation nothing but what and symbolic representation, we are going to be called it as what a symbolic representation, we are going to be called it as what notations. And inside the asymptotic notations, for time calculation and for representing whether it is a with best case or average case or worst case, to represent that means we are using some symbolic notations. Those symbolic notations we are indicating it as what some big O notation or omega notation, big omega notation, or we are going to be called it as what theta notation. We are going to be called it as what theta notation. And yesterday's class we have been discussed it as what is meant by these three notations. Here what is the thing we need to be understood here is big O notation means what is the thing we need to be remember here means if it is taking a maximum amount of time, something as worst case time complexity. If it measures the worst case time complexity and the longest amount of time taken by the what algorithm possibly takes to the what complete, then such type of representations we are going to use some notation as what is the notation we are going to be used here is big O. And what is the thing we are saying here, it measures the worst case time complexity. It measures the worst case time complexity. And if a functionality is taking more time than expected time, then what is the such type of time complexity we are going to be represented by using the word big O. Here f of n is our function and g of n is other function. If our function is occurring as a lower bound, our function is occurring, f of n, okay, f of n is what is the f of n is one function and g of n is one more function. And suppose if you treat these axes as one axis as what, time, one axis as what, time taken for execution of the program, how much amount of the time taken for the execution of the program. And here g of n is taking more time compared to the what, f of n. Then we are going to be called it as what, worst case. And okay, such worst case is going to be represented by using a symbolic notation as what, big O. Now we are going to see after this notations, we are going to see how we are going to represent the time complexity values here. And here, what is the big O means? What is the thing we need to remember? Big O means what is the thing we need to remember? Worst time complexity, we are going to be called it as what, big O. And here best case time complexity, we are going to be called it as what, omega. Best case time, we are going to be called it as omega. It is this graph is showing extremely opposite to the what, big O notation. This graph is showing extremely opposite to the what, big O notation. Here f of n is occurring as upper bound and g of n is occurring as lower bound, and g of n is taking the less time compared to the what, f of n. And so we are indicating that time complexity representation by using something as what, omega notation. We are indicating by using the what, omega notation. Omega is a formal way to express the lower bounds of algorithm running time. And it measures what, it measures which type of time complexity. Here means best case time complexity it is going to be measured. It is going to measure something as what, best case time complexity. And what is the other notation we are having here means, if you are having multiple functions and f of n is occurring as an lower uh, occurring in between what, g1 of x and g2 of x, or g1 of n and g2 of n, means we are going to be called it as what, we are going to be called it as what, um, average case. And that average case representation, we are going to be indicated by using the what, average case is indicated by using the which one, theta notation. Here average case is indicated by using the what, theta notation. And now we are going to see how, when you are going to indicate one is going to be indicated when, and log n is going to be indicated when, and n we are going to indicate when, and n log n, like this. N square is when we are going to indicate n square, when we are going to indicate n power 3. uh, one means what is the thing we are indicating, notation as what, constant. Log n means we are indicating it as what, logarithmic. And n we are indicating for the what, linear. N log n we are indicating it as n log n itself. N square we are indicating it as what, quadratic. N power cube we are indicating it as what, cubic. And n power o1 we are indicating it as polynomial. 2 power on we are indicating it as what, exponential. And not only these three notations we are going to have, we are going to have other two notations, and small o notation and small omega notation we are going to have. Yesterday's class we have been seeing something as what, when we are going to have small o, when we are going to have big O, when we are going to have omega, when we are going to have theta, these things. Big O means what is the logic we need to be remember, less than or equal to. If the time is less than or equal to f of n, time is less than or equal to g of n, means we are going to be represented by using the what, big O. If the f of n time is less than, if the f of n time is less than g of n, means what is the O representation we are going to be indicated, small o we need to be indicated. And if f of n is greater than or equal to, means we need to indicate it as what, omega notation. We need to indicate it as what, omega. And f of n is equal to what is the when we are going to indicate something as small omega means if it is greater than, if f of n is greater than g of n means we are going to be indicated it as what, small omega. And if it is f of n is equal to theta of g of n means we are going to indicate something as what, theta notation. We are going to be indicated, we are going to indicate it as what, theta notation. And this is the tabular format we need to be remember for the what, when we are going to indicate it as big O, when we are going to indicate it as what, small o, and when we are going to indicate it as what, big omega, when we are going to indicate it as what, small omega, and when we are going to indicate it as what, theta. And this is the one table we need to remember. And what are the different types of asymptotic notations we are having here means, in most of the textbooks they are going to explain about these three notations. What are the three notations we are having? Big O notation, big omega notation, and a theta notation. And why the notations are going to be used here means, for the purpose of what, best case, average case, and worst case. To represent best case means what is the notation we are going to use. To represent the average case means what is the notation we are going to be using. To represent the worst case means what is the notation we are going to be using. And big O for what is the thing we need to be remember, worst case time. And omega we need to represent it as what, omega is going to be, big omega is going to be used for the what, best case time. And theta notation we are going to be used for the what, average. And for theta, this type of graph we need to be remember for exam point of view. If you are explaining about the theta notation means you need to explain, you by using this diagram you are going to explain f of n is occurring as an a lower bound and upper bound for the g of n means we are going to be called it as what, theta notation. And if f of n is occurring as an upper bound to g of n means we are going to be called it as what, omega notation. And if f of n is occurring as a lower bound to g of n means we are going to be called it as what, omega big O notation. And now we are going to see what is the important point to be noted here means, when we are going to call it as O of n, O of 1, when we are going to call it as what, log n, and when we are going to call it as what, linear. And these how we are going to, how when we are going to represent these things we are going to be discussed here. And all of you up to here it is okay, but we need to have some knowledge on how we are going to represent this common asymptotic notations. Inside the common asymptotic notations, what are the things we are having? Constant, logarithmic, linear, n log n, quadratic, cubic, polynomial, exponential. And here what is the, all of you just see this particular site. And inside this site what are the things we are having, all of you see carefully here. And here what is the uh, okay. And here what are the things we are having, all of you see carefully here. Here we are calculating something as what is the complexity we are calculating? Time complexity. We are calculating something as what, uh, okay, we are calculating something complexity called what, time complexity. And here what is the, inside this time complexity, inside this time complexity, how the calculation is going to be done, how the calculation is going to be done using the time for calculating the time. And here all of you know what is meant by the time complexity means what, it is a number of times each statement of the logic gets executed to produce the required output. It is the number of times each statement of the logic gets executed to produce the required output. And now what is the thing we want to know here means, what is the important thing we want to know here means, important thing we want to know here means, when we are going to indicate O of 1, when we are going to indicate O log n, and when we are going to indicate O of n, like this. And here we are having one simple program. And inside this simple program we are having two variables as what, int I and n is equal to 5, and int I and n is equal to, what is the thing we are having, 5. And here we are having one for loop. Here we are having one for loop, and this for loop is going to be executed for how many times? This for loop is executing this printf statement for how many times? Output statement for how many times here means 1 to n times. 1 I less than or equal to what, n. So here in this scenario, we are going to indicate the time complexity as what, how many times this output statement is going to be executed here means how many times this output statement is going to be executed. Here the for loop gets executed how many times? N number of times. Hence the time complexity we are indicating it as what, O of n. uh, Here how many number of times it is executing here means n number of times. N number of times, so we are indicating the time complexity as what, we are indicating the time complexity as what, O of n. We are indicating some time complexity as what, O of n. O of n is indicated for O of n is indicated for what? O of n is indicated for what? O of n means what? Linear. Linear. And here O of n is executed for how many number of times here means n number of times. N number of times if you are using a for loop and if you are executing one statement for n number of times means the time complexity you are going to be indicated by what? O of n. And suppose here what is the uh, here what is the thing we are having here means here we are having one program, and here the output statement is going to be executed only for one time. The output statement is going to be executed only for one time. And then how we are going to represent this time complexity means here we are indicating the time complexity for this program. We are indicating the time complexity as what is the time complexity we are indicating? O of 1. Why? Because the statement is going to be executed only for one time. That's why we are indicating it as what? That's why we are indicating it as what? O of 1. We are indicating it as what? O of 1. Uh, when we are going to indicate O of n, when we are going to indicate O of n, the statement is going to be executed for how many number of times? N number of times. So we are indicating the time complexity as what? O of n. And here the statement is executing only for one time. Executing only for one time. So we are indicating it as what? O of 1. O of 1. I think all of you get one idea. What is the thing you have been understood? If the here the printer statement is going to be executed only for one time, that's why we are indicating the time complexity as what? O of 1. Here the here the statement is executed for how many times? Here we are having the statement inside a for loop. The statement is going to be executed for n number of times. So we are indicating this time complexity as what? O of n. And we have got an idea about when to represent O of 1 and when to represent O of n. And now here we are having something as what? Here we are having one for loop. Here we are having the what are the two output statements we are having here means sum is equal to some place array of we are having, and what is the output statement we are having here means return sum. We are having some statement as what? Return sum. Then what is the how many times this statement is going to be executed? Sum is equal to some place array of I is going to be executed for what? How many times it is going to be executed? Sum is equal to some place array of what? I. Array of I. Then it is going to be executed for how many number of times here means n times it is going to be n times it is going to be executed, n times it is executing. And here why we are indicating even though why we are indicating it as what? N plus 3. Here we are indicating it as what? N plus 3. Why we are indicating this plus 3 here? Plus 3 అనేది ఎందుకు ఇండికేట్ చేస్తున్నాం? And here why we are not indicating it as what? O of n. Why we are indicating it as what? O of n plus 3. Why we are indicating O of n plus 3 means here we are calculating something as what these two statements. This statement is going to be executed for n number of times, but here what are the operators we are used for displaying? What are the operators are involved in displaying the output? Here what is the operator? Assignment operator we are having. Here we are having plus operator, and here we are having one return operator, return statement. So here we are going to use something as what? Here we are using uh, assignment, plus, and return. Those things we are indicating it as what? 3. That's why we are indicating here, we are indicating the time complexity as what? That's why we are indicating the time complexity for this code. We are indicating it as what? Time complexity as what? O of n plus 3. O of n plus 3. Why we are indicating O of n plus 3 here means inside this output statement, some operators has been involved. How many operators has been involved to displaying the output means assignment, plus, and a return. So 3 operators has been involved. So we are indicating O of n plus 3 as what? O of n plus 3 as what? Time complexity here. We are indicating the time complexity as what? O of n plus 3. And when we are going to indicate something as what? O of n square here. When we are going to indicate it as what? O of n square. When we are going to indicate O of n square here means if a for loop is existed within a for loop, nested type for loop statements we are using, and inside this we are displaying one statement as what? We are for displaying the output we are using one printf statement. How many times it is going to be executed here means n into n times it is going to be executed. N into n times it is going to be executed. And a single for loop means n times. And here a for loop within a for loop, that's why we are calling it as what? N by n into n. So we are indicating it as what? For the time complexity for this particular statement, we are indicating it as what? We are indicating it as what? O of n square. We are indicating it as what? O of n square we are indicating. That's why we are indicating it as what? O of n square. All of you got an idea about what is how when we are going to indicate O of 1. O of 1 అనేది ఎప్పుడు indicate చేస్తాము? If the statement is going to be executed only for one time means we are going to be indicated it as what? Only for one time means we are going to be indicated it as O of 1. If the statement is going to be executed for the what? If the printer statement is going to be executed for the what? N number of times means we are going to indicate it as O of n. And when we are going to indicate something O of n plus 3 means here we are not having some printer statement. Here we are, the output is assigned to the what? Sum, and the output is returned by using one return statement. And while assigning, what are the operators we have been used? Assignment operator and plus operator, and return statement we have been used. So we are indicating this statement is going to be executed for n times, but what are the other operators has been involved for displaying here means plus 3 operators has been involved: assignment, plus, and return. So we are indicating it as what? O of n plus O of n plus 1 statements we are indicating. We are indicating it as what? O of n plus 3. And n square means what is the thing you need to be remember? O of n square is going to be indicated when if you are using a nested for loop, and if a statement is executed for n into n number of times means we are going to we are going to indicate it as what? O of n square. We are going to indicate it as what? O of n square. And when we are going to indicate a log n functionality here, when we are going to indicate something as a log n functionality, logarithmic O of log n, when we are going to be used. When we are going to use log n here means recursive. Inside the function we are having, if the function is calling in a recursive manner means recursive division of elements into uh, Havels, and will have what? O of log n complexity. We are having something as what? O of log n complexity. Okay, if here division is occurring as a recursive manner, So we are going to indicate it as what? O of log n complexity. And I think all of you got best idea about what is the, when we are going to represent something as O of n, and when we are going to indicate it as O of log n, and when we are going to indicate something as O of n, these things. N square means what? A for loop. Within a for loop, we are going to be called it as what? We are going to, for displaying the output, we are using nested for loop. Means nested for loop means a for loop. Within a for loop means we are going to use quadratic. Only one output statement means we are going to indicate it as what? O of 1. And the printf statement is executed for n number of times means we are going to indicate it as what? O of n. And okay, these are the things we are going to be used for representing the what? Time complexities. And here space complexity means what is the thing they are indicating. Space complexity means what is the thing they are going to be indicated. What is the thing? Space complexity means one formula they are indicating: auxiliary space plus space by space used by the water input values. Auxiliary space plus space used by the used by the input values. This is all about water space complexity here. How much amount of the space it is going to be occupied. And